Imagine presenting a revolutionary idea to a room of powerful family members, only to have them dismiss your life's work as a foolish, expensive dream. That was the scene in 1927. Roy Fedden stood before them, holding blueprints for an engine that could either secure Britain's future or become his financial ruin. The board declined. His accountants declared it impossible. His rivals called it professional suicide. Yet a dozen years later, as German bombers swarmed the skies above London, it was Fedden's impossible engine that denied them their prize. This is the tale of the man dismissed in the war's most crucial hour, the innovator whose sleeve valve concept was so perilous to create that it nearly broke him, and the quiet visionary who engineered over half of the Royal Air Force's engines while a family of cousins claimed the glory. Born in June 1885 in Bristol, England, Roy Fedden entered a world of privilege, but one that came with rigid expectations. His father, a prosperous sugar broker, was influential and well-connected, a man who foresaw his sons in smart suits attending social events. But in 1903, an event occurred that would redirect Roy's destiny forever. His father acquired one of Bristol's first automobiles. While the family saw it as a new status object, the 18-year-old Roy viewed it as an intricate puzzle. He disassembled it. He examined every cog, every poppet, every drive shaft. He understood with pure instinct that internal combustion was the path forward. His family sent him to Clifton College with hopes he would adopt a more respectable life. He was a spectacular failure. He had no interest in Latin or classic literature. He filled the margins of his school books with sketches of engine components. Upon graduating, his family expected him to join the military, the standard path for young men of his standing. Roy flatly refused. He declared his intention to become an engineer. His relatives were aghast. Manual labor was for the working class, but Roy was indifferent. In 1906, at 21, he completed his apprenticeship and promptly conceived an entire automobile design. He persuaded a local firm, Bristol Hercules, to employ him. They manufactured his car. It was named the Shamrock. It was a notable success. Roy Fedden, at just 22 years old, was already their chief engineer. Then 1914 arrived, and with it, the Great War. The world suddenly had a desperate need for engines, specifically for aircraft. Bristol Hercules shifted from cars to aviation. They started overhauling Rolls-Royce engines, Hawks, Falcons, and the iconic Eagle. Roy, now 29, was managing the entire facility. It was during this period that something remarkable transpired. Sir Henry Royce himself, the founder of Rolls-Royce, extended an offer to Roy for a senior role. Consider that for a moment. Rolls-Royce was already a name synonymous with excellence. It was the absolute peak any engineer on the planet would have accepted. Roy declined. Why would he do that? Because in 1915, Roy had begun sketching his own aero engine. He had a specific vision, a radial engine, air-cooled, elegantly simple, and immensely powerful. He collaborated with a draftsman named Leonard Butler. The pair became a formidable team. Every part they created together was marked with the initials FB for Fedden Butler. They were a true partnership. They developed two engines during World War I. The first was a 14-cylinder radial named the Mercury. The second was a 9-cylinder monster called Jupiter, 400 horsepower. These power plants were completely revolutionary. But when the war concluded in 1918, no one wanted them. The world was financially devastated. The aviation industry was contracting. Orders disappeared almost instantly. Roy and Leonard persisted. They established a new venture named Cosmos Engineering. They invested everything they had into it. They possessed 7 functioning Jupiter engines. They had the plans. They had the expertise. What they lacked was capital. By 1919, Cosmos had declared bankruptcy. Roy Fedden, the man who said no to Rolls-Royce, was on the verge of losing it all. Then the British Air Ministry intervened. They recognized the Jupiter's potential. They knew Roy was a prodigy. So they discreetly informed the Bristol Aeroplane Company that it would be a very good idea to acquire Cosmos Engineering. The board was hesitant. The company was managed by a single family, cousins, nephews, and sons of the founder, Sir George White. Not a single one was an engineer.
None of them grasped engine technology. They were suspicious of Roy. He was too driven, too much of a perfectionist. He involved himself in everything, from the training of apprentices to the sales process. He challenged their control. But the Air Ministry was insistent. So in 1920, Bristol grudgingly acquired Cosmos. They spent £15,000 for Roy Fedden, Leonard Butler, 7 Jupiter engines in all their designs. It was the deal of a lifetime, and Bristol was clueless about what they had just bought. The Jupiter engine became a global sensation. It was licensed for use all over the world. Germany licensed it, Italy licensed it. Fedden's radial engines were seemingly everywhere. By the close of the 1920s, Roy Fedden had risen to become the best-paid engineer in all of Europe. His 1920 royalty agreement had made him extraordinarily wealthy. But Roy was not content, because in 1927 he studied a paper written by Harry Ricardo, another celebrated engineer. Ricardo contended that the era of the poppet valve was drawing to a close. Poppet valves, the standard type in all engines, had inherent restrictions. They couldn't move enough air. They couldn't cope with high compression. They were the ultimate bottleneck. Ricardo suggested a different approach, the sleeve valve. Instead of valves moving up and down, you would have a cylindrical sleeve that slid and rotated between the piston and the cylinder. Ports cut into the sleeve would align with ports in the cylinder wall, admitting the air-fuel mixture and expelling exhaust. It was a beautiful, simple concept. In theory, it was perfect, but a massive problem existed. No one could reliably manufacture it. The required tolerances were microscopic. The sleeve needed to be perfectly circular to within 2/10,000ths of an inch. It had to glide effortlessly at 2,000 cycles per minute while enduring combustion forces that could fracture steel. It needed to be hard enough to resist wear, but not so brittle that it would crack. For an entire decade, the world's finest engineers had attempted to make sleeve valves functional. All of them had failed. The sleeves would seize up, they would leak oil, they would shatter. The technology was deemed cursed. Roy Fedden absorbed Ricardo's paper and became obsessed. He knew that if he could solve the sleeve valve puzzle, he could create the most powerful engines on Earth. Sleeve valves offered advantages that poppet valves simply could not match. In a 2-row radial engine, fitting 4 poppet valves per cylinder was nearly impossible due to the geometry. You were stuck with 2 valves, which starved the engine of air. But with sleeve valves, you could design 5 large ports per cylinder. This meant massive airflow, greater efficiency, and more power. Furthermore, sleeve valve combustion chambers were perfectly smooth. No hot exhaust valves protruded into the chamber to create hot spots. This meant you could run much higher compression without dangerous detonation. You could use lower octane fuel and still generate more power. It was the ultimate prize, only if the sleeves could be manufactured. In 1927, Roy Fedden started his experiments. He tested various alloys, different machining methods, and a range of surface coatings. Every single try ended in failure. The board at Bristol grew anxious. Roy was pouring huge sums of money into a technology that was yielding no results. They ordered him to stop. Roy refused. He believed. In 1934, 7 years into his quest, Roy achieved a major breakthrough. He developed a 9-cylinder radial called the Perseus. It produced 750 horsepower. It incorporated sleeve valves, and for the very first time, it actually worked. It ran without a hitch. It did not seize. The Royal Air Force tested it in a Wildebeest torpedo bomber. 200 hours of operation showed no failures and required minimal servicing. When they disassembled the engine, it was in immaculate condition. The sleeve valve era had dawned, but there remained a gigantic obstacle. Every single Perseus engine was painstakingly assembled by hand. Cylinders were individually lapped and matched to their sleeves. Pistons were custom fitted. It took weeks just to build one engine, and Britain was on the brink of war. During the mid-1930s, Roy Fedden journeyed to Germany. He had been invited by the Nazi regime, who were eager to display their industrial power. They gave him extensive tours of their factories. They showed him the Messerschmitt 109. They showed him their Junkers bombers. Their goal was to intimidate him, to convince him that Germany was invincible. But Roy wasn't intimidated. He was horrified. He realized Britain was in grave danger. The Germans were constructing vast air fleets, and Britain possessed nothing that could challenge them. When Roy got back to England, he went straight to the Bristol board. He insisted they had to expand production on a massive scale, immediately. They needed 14-cylinder engines, 18-cylinder engines. They needed to mass-produce sleeve valves. The board said no. They failed to grasp the urgency. They didn't comprehend the threat. Roy was incandescent with fury, but he continued his work. In 1935, he commenced the design of a new engine. It would have 14 cylinders in 2 rows, with 38.7 liters of displacement. He named it the Hercules. It was destined to become the engine that would save Britain. But first, how could he possibly build it in large numbers? The primary issue with mass-producing sleeve valves was achieving perfect roundness. If a sleeve was even fractionally out of round, it would seize solid within minutes of starting. Conventional machining simply couldn't hold the required tolerances. Roy tried everything: different lathes, new grinding wheels, various heat treatments. Nothing was working. He pushed his team relentlessly. They endured 18-hour workdays. They evaluated thousands of combinations of materials and procedures. The Bristol board was rapidly losing its patience. Roy was burning through cash at a terrifying pace, but Roy had no other option. War was imminent. Then, in 1939, just months before World War II ignited, Roy's team stumbled upon centrifugal casting. By spinning the mold as the metal cooled, they could consistently create sleeves that were perfectly round every single time. The Hercules could finally enter mass production. 1939, September 1st, Germany invaded Poland. World War II had started, and Britain's air arm was desperately unprepared. The Bristol Blenheim bomber, a critical aircraft at the outset of the war, was powered by Bristol engines. The Bristol Beaufort torpedo bomber, the Bristol Beaufighter heavy fighter. All of them needed engines. The Hercules was ready in the nick of time. By 1940, the Hercules was demonstrating its worth: 1,375 horsepower, smooth running and dependable. The Beaufighter, armed with 2 Hercules engines, became one of the war's most formidable aircraft. As a night fighter, it hunted German bombers over Britain. As a strike aircraft, it sent German shipping to the bottom of the Mediterranean. The deep, resonant thunder of the Hercules became synonymous with Britain's command of the air. But the Hercules wasn't only for fighters. It propelled the short Stirling, Britain's first 4-engine heavy bomber. It powered the Handley Page Halifax, one of the key bombers in the strategic campaign against Germany. Later models of the Avro Lancaster, the legendary bomber that executed the Dambusters raid, also used the Hercules. By the war's end, more than 57,000 Hercules engines had been manufactured. That's more than any other British engine except for the Merlin. Fedden's sleeve valves powered close to half of the Royal Air Force. A dismissed idea had become Britain's shield. But Roy Fedden would not receive the credit. Why? Because in 1942, at the war's peak, the board at Bristol fired him. It all began with a knighthood. In January 1942, Roy Fedden was knighted for his immense contributions to the war effort. Sir Roy Fedden. It should have been his most triumphant moment, but the board at Bristol perceived it as a challenge to their authority. Roy was already a public figure. He was the recognizable face of Bristol engines. He delivered speeches, he published articles, he was a consultant to the government. The board, the cousins, felt completely overshadowed. They craved control. So they proposed a new role for Roy, technical controller. It sounded prestigious, but there was a hidden condition. His entire design team would answer to the production manager. Roy would be in charge of research and development, but another person would control his personnel and his funding. It was a calculated insult. Roy refused. He stated that he required absolute control over all experimental and design activities. The board refused his demand. Neither party would yield. In February 1942, the board gave Roy 6 months' notice. They stripped his authority effective immediately. And in the summer of 1942, in the thick of the most consequential war in modern history, Roy Fedden was out. The most brilliant engine designer Britain had ever known, the man who had effectively saved the Royal Air Force, had been ousted by a board of relatives with zero engineering knowledge. The British Parliament was in an uproar. Lord Brassabon, a pioneer of British aviation, delivered a scathing speech in the House of Lords. He referred to the Bristol Board as the cousins, his contempt obvious in every word. He highlighted that Roy Fedden had designed 75 different engines that were built in Britain, Germany, Italy, and America, that these engines collectively produced 75 million horsepower. Or if you made London 12 times bigger, it was the horsepower of all the buses required to serve a city that enormous. No individual in history had given more to aviation than Roy Fedden, and Bristol had discarded him. The government was appalled. The Air Ministry had tried for years to secure Fedden a seat at the Bristol Board. The cousins had consistently refused. When the Ministry of Aircraft Production requested to borrow Fedden in 1940, Bristol refused, claiming he was too vital. But now, in the war's midpoint, they had cast him aside. It was a public scandal, but nobody could do anything. The Bristol Board owned the company. They were free to do as they wished, and what they wished was for Roy Fedden to depart. Roy did not cease his work. He became a technical advisor to the Ministry of Aircraft Production. He traveled to the United States with another Bristol employee, Ian Duncan, to study American manufacturing methods. He spent months inside American factories, observing how Ford and General Motors were adapting automotive mass production for aircraft engines. He took meticulous notes. He authored reports. He consulted on high-octane fuel development, urging Britain to produce 100-octane fuel that would give British engines a crucial power advantage. He helped found the Rotol Propeller Company, a joint venture between Bristol and Rolls-Royce that made the variable pitch propellers so essential to the war effort. Without Rotol, British fighters would have been at a severe disadvantage. The propeller was just as vital as the engine, and Roy knew it. He was indispensable to the war effort. Government ministers sought his advice constantly, but he was no longer designing engines. The one thing he cherished most, the work that was his identity, had been wrested from him by men who couldn't design a bicycle, let alone a high-performance aircraft engine.
In 1945, right after the war concluded, Roy led a mission to Germany. It was called the Fedden Mission. He toured German industrial sites. He inspected German engines. He visited the V-2 rocket production sites and the horrifying labor camps at Nordhausen. He compiled detailed reports. His conclusion was that German engines were technically behind British engines in supercharger design and power-to-weight ratio, but their fuel injection systems and single-lever engine controls were superior. Britain needed to learn from them. Roy returned to England to attempt a career revival. He and Ian Duncan started Roy Fedden Limited. They designed a small, horizontally opposed six-cylinder engine for light aircraft. It was a brilliant design. Fuel-injected, sleeve valve, compact. It was technically far ahead of anything being made in America, but it never reached production. The company grew too fast. They accepted too many projects, including an air-cooled radial car engine that suffered from vibration and cooling issues. By 1947, Roy Fedden Limited entered liquidation. Roy was 62. His days of building engines were finished. But Roy had a final battle to wage. For years, he had been a vocal proponent for a college of aeronautics in Britain, a place for engineers to receive proper training, where research could happen free from the interference of corporate boards. He campaigned for it tirelessly, and in 1946, Cranfield College of Aeronautics was founded. It would later become Cranfield Institute of Technology, and then Cranfield University. It is now among the premier aerospace engineering institutions in the world. That was Roy's ultimate legacy. Not the engines, not the patents, but the generations of engineers he trained and motivated. Roy Fedden lived out his later years in quiet retirement. He consulted from time to time, he gave lectures and wrote articles, but he was mostly forgotten. The jet age had dawned. Turbines were replacing pistons. The Hercules, the Perseus, the Centaurus, all the magnificent radial engines were becoming obsolete. Roy lived long enough to witness his life's work relegated to history. On November 21, 1973, Sir Roy Fedden passed away at 88. There were no large funerals or state ceremonies. He was buried without fanfare. The man who engineered over half the engines for the Royal Air Force, who kept Britain aloft during its darkest period,
was almost completely erased from memory. But his engines were not, because even now, if you go to the Yorkshire Air Museum, you can hear a Bristol Hercules engine thunder to life, that deep, rumbling noise that once dominated Britain's skies. And if you know what you are hearing, you realize it is not merely an engine. It is an engineering miracle. Inside that machine are 14 cylinders, each containing a sleeve valve turning at 2,000 RPM. Those sleeves were made to tolerances considered impossible in 1927. They were realized by a man who was told it was impossible, who was ridiculed by boards and rivals, who was fired at his moment of greatest success, but who never ever stopped believing. Roy Fedden didn't just construct engines, he forged weapons. Every Hercules engine powering a Beaufighter, every Sterling dropping bombs on Germany, every Halifax bringing its crew home safely was a weapon created by a man who knew that power without control is worthless. The poppet valve was the conventional route. Everybody built poppet valve engines. They were established, safe, and predictable. But Roy understood that to win a war, you cannot afford to be conventional. You must embrace risk. You have to solve the problems that everyone else dismisses as unsolvable. You have to build engines that are so advanced, so efficient, so powerful that they give your pilots an advantage measured in horsepower and precious minutes of survival. The Hercules produced 1,615 horsepower in its Mark VI version. Later variants exceeded 2,000 horsepower, but the figures alone don't capture the whole story. What made the Hercules so special was not just its power, it was its smoothness. Pilots reported it just murmured, a deep thrumming sound that hinted at immense power. It was the reliability. Hercules engines ran for thousands of hours, requiring very little maintenance. It was the fuel economy. Sleeve valves permitted higher compression, which yielded more power from less fuel. That meant longer range, more bombs on target, more enemy ships sunk, and more German fighters downed. The Hercules didn't just assist in winning the war. In many respects, it dictated how the air war was fought, and Roy Fedden designed every single critical part. But here is the real tragedy. Roy Fedden is a footnote in most history books. Ask anyone to name a World War II engine designer, and they'll likely say Rolls-Royce or mention the Merlin, or perhaps the Pratt & Whitney engineers from America. Almost no one recognizes the name Roy Fedden. Why is that? Because Rolls-Royce was a powerful brand. Merlin had a romantic name. It powered the Spitfire, the most celebrated fighter plane in history. It powered the P-51 Mustang. It had excellent publicity. It had a mythology. The Hercules powered bombers, the unglamorous workhorses that flew at night, dropped bombs, and didn't receive the same glory. And Roy himself was deliberately pushed aside by the Bristol board. They ensured he was not linked with their success. They wanted that credit for themselves. But here's what the cousins at Bristol failed to understand. You can't fire genius. You can remove a title, you can take an office, you can strip away authority, but you cannot erase the engines. 57,400 Hercules engines, 75 million horsepower from Fedden-designed engines globally. Each one is a testament to the man they attempted to bury. And it wasn't only Hercules. The Jupiter had been licensed by France, where it was developed into the Gnome-Rhone engine. Japan licensed it and built thousands. Poland, Czechoslovakia, and the Soviet Union all produced versions of Fedden's Jupiter design. His engines quite literally fueled global aviation between the wars. The Centaurus, his 18-cylinder magnum opus that produced over 3,000 horsepower, powered the Hawker Sea Fury, one of the fastest piston-engine fighters ever constructed. Even after the war, the French Supny Snecma built Bristol sleeve valve engines under license for transport planes. The design was so effective, so fundamentally correct, that it continued working well into the jet age. The sleeve valve was meant to be impossible. Everyone agreed. Continental Motors in America spent a fortune trying to create one and then gave up. Rolls-Royce tinkered with sleeve valves and decided they were too difficult. Napier tried with their Sabre engine and encountered endless issues until Roy's team at Bristol were compelled by the Air Ministry to reveal their manufacturing secrets. Even then, Napier had difficulties. Only Roy Fedden solved it. Only Roy possessed the obsession, the perfectionism, the utter refusal to accept defeat, to push through 7 years of failures until the Perseus ran smoothly, and then to scale it to the Hercules, producing 57,000 engines that performed reliably in combat under the most brutal conditions imaginable. That is not just engineering, it is artistry, it is genius. It is a man who understood that the margin between victory and defeat is measured in thousandths of an inch, in the perfect roundness of a sleeve, in the choice of an alloy, in the resolve to test one more combination when all others have surrendered. What did Roy receive for it? A knighthood, a forced exit, a failed post-war business, and decades of being overlooked. But perhaps that's all right, because the engine spoke for him. If you found this forgotten story of genius and betrayal as fascinating as we did, please hit the like button. It really helps the WWII Record Hub channel grow. When a Beaufighter pilot advanced the throttles and felt the Hercules engine surge, he didn't think about Roy Fedden. He thought about his mission. He thought about returning home alive. And that is precisely how Roy would have wanted it. Engineers don't build engines for fame. They build them to function, to save lives, to give their side a winning edge. The Hercules accomplished all of that. It provided Britain with air superiority when it was most needed. It powered the bombers that shattered Germany's industrial might. It powered the fighters that defended the homeland. And every single one of those engines carried a piece of Roy Fedden's soul. So, the next time you read about World War II and see a photo of a Halifax bomber or a Beaufighter, examine the engines, those large radial power plants with the deep cowlings. Inside each one are 14 sleeve valves, rotating perfectly thousands of times per minute, moving air with an efficiency once thought impossible. That is Roy Fedden, the man they ridiculed, the man they said couldn't succeed, the man they dismissed, the man who won the war all the same. Because ultimately, it doesn't matter what the board thinks. It doesn't matter what the accountants say. It doesn't matter if you receive credit or recognition. What truly matters is whether your engines work. And Roy Fedden's engines worked. They worked better than anybody else's. They worked when Britain's very survival was on the line. And they kept on working long after the war was over, powering civilian transports and military cargo planes, keeping Roy's legacy alive in the skies, long after the world forgot his name. That is the quiet strength of engineering genius. It doesn't require applause, it just needs to work. And Roy Fedden's engines never stopped working.